Hey guys, Smail here for another video about AI for businesses. Last month I closed a client for a big AI project that is worth $62,000. We should be starting with that project by the end of January, but I wanted guys to show you a real life example of an AI consulting project with a real client. If you're a business owner and you're wondering what in practice can AI solve for businesses and what can explain this price tag, this video is for you. In this video, I'm going to tell you who the client is, what's the problem they currently face, why do they want to solve it, how I'm going to solve it for them, and I will also show you a detailed cost breakdown that explains the final cost of $62,000. After that, I'll tell you why I decided to take this project and some final interesting remarks and notes. And by the way guys, a little spoiler alert, this is not about generative AI. It's actually about a type of AI that existed a long time before ChatGPT. So you're not gonna be hearing about ChatGPT, Gemini, Midjourney, or any other tools that you heard about those last 2 years. Let's get to it. Okay, so first of all, who is the client? Of course, I can only tell you the type of business of this client. So they are a Canadian manufacturing company. More specifically, they are in the precision manufacturing industry. So basically, they own a type of machines called CNC machines, which produce highly accurate pieces of equipment. So those can be car parts, for example. Basically, anything mechanical is made of parts which can be created through a CNC machine. I will now play a small clip of how those machines work. Okay, so first here we can see the input material that will serve for the final object. So you can see that it's a robot that just places it in the right position. That metal is actually stainless steel. And you can see here there is a machinist that is placing the right tools that will serve for drilling and milling. Now this is the final piece that they want to get. So first they will use a software, that will simulate how those tools will, cut into the stainless steel. Then once everything is ready, the actual cutting starts. So you can see that the block of metal is spinning very fast. And at the same time, there is a tool that is cutting in it. And you can see some kind of fluid that is pouring into those objects. So I guess it's to prevent from heating, right? And you can see here the final object that we get, a beautiful piece of stainless steel, which is highly accurate. And this video shows all those little tiny metallic parts that are left out after the milling and drilling. Those are called chips. And that's pretty much how a CNC machine works. Basically, those businesses work for large industries like aerospace, automotive, or medical devices. This specific client of mine has thousands of clients. One of them is Pratt & Whitney, one of the world-leading manufacturers of jet engines. Actually, one of their engines is used in the US F-35 stealth jet fighter. And this client wanted me to solve a specific thing in their process using AI. Okay, so before I talk about the exact problem, I want to tell you guys about a special offer I'm running only through this month of January 2025. This month I'm launching a very limited offer of building AI/automation prototypes for a very affordable cost. Normally those prototypes start at $3,500, but I will do that for only $750. And it will be limited to 4 people only to make sure I deliver quality projects. And this deal will only last during the month of January. I'm doing this because I want to encourage more people and businesses to adopt AI and automation, but I limit that to only 4 seats because I'm busy handling other AI projects. Okay, so now going back to the problem this client has. It has to do with their quality control process. Basically, once a component is made, they need to make sure that the dimensions are correct and within specific tolerances. And let me show you what I mean exactly. So this is a technical drawing they sent me. It's from one of their clients. It represents a pipe that needs to be made. This is a very simple component. There are others that are much more complex to make. As you can see, this drawing has multiple types of information. I've hidden some parts, obviously. But the most important part is those measurements that you can see here. So once this pipe is created, someone will manually measure the different dimensions. And this person will do that from a document that we call the inspection report. And this is what the inspection report document looks like. This inspection report is created manually right now for every single type of object that is produced by this company. Now I will show you the technical drawing and its corresponding inspection report. So currently there is a human that is going through every single measure to create this document. We can see that the measures have a very specific order. They are reported from left to right for each view, and within a view they are written in a clockwise way. So this client told me that it takes from 3 to 7 minutes to create this document, depending on the complexity of the drawing. So let's say if this step is repeated 1000 times per month and it takes them 4 minutes on average, it means it takes them 4000 minutes or 66 hours each month to complete this task manually. So they basically want me to come up with an AI system that will analyze any technical drawing, extract the measures, and quickly create an editable document like a Word document with those measures reported on them in that specific order. That's very simple, right? Right now there are humans who do that as part of their job. The reason why they want to tackle this issue is very simple. They prefer to pay now the salary of someone once and for all for an AI project instead of hiring someone that will do that and be paid every single year. Basically, they prefer to pay 60k now instead of hiring someone for 60k and pay them that same amount every single year, plus all the headaches involved with human resources. Plus, after the automation of this task, the people who do that currently will be able to do other tasks of higher value. Okay, so now we move on to how I'm going to solve this problem. The first step that I did was to search if this problem was already solved or not. Meaning if there are AI models that are trained on technical drawings to extract the measurements that are accurate enough and open source to be used directly without training any new model. So I went to Google Scholar to see what the AI literature says about this specific problem. So I went to scholar.google.com, and normally when there is a problem that is popular, you'll find at least 10 to 15 papers about it written by AI researchers. For this issue, there were only 3 papers. Now, of course, this does not mean there are no AI models currently being used by other precision engineering companies. They might be proprietary. This just means that we will have to train the AI models. Some other remarks that I had concerning those 3 papers is that the data set used was very limited. Only 300 drawings in one of them. AI and deep learning models are data hungry, and 300 drawings are not enough to have very accurate models. Luckily, my client has more than 5,000 drawings. Also, one of the papers used synthetic data to train, which is not a very good approach if you want to develop an AI model that will be accurate when facing real-world data. Now, all of this work led me to one conclusion: this will be a research and development project. It's more in the domain of research rather than just taking an existing and proven method to apply it for them. Luckily, I have experience in research because I published multiple AI papers where we trained AI models from scratch for very specific use cases. And after I asked the opinion of 2 AI engineers who are friends of mine, they believed it was possible to achieve accurate results, but with a very rigorous and methodical approach. I don't know if you know it, guys, but AI research is a high-risk, high-reward field. You might do a lot of experiments and not reach your goals. However, if you do research and you make a breakthrough, it can literally be a jackpot. Actually, the paper "Attention is all you need" was part of Google research, and this was a type of model that led to the birth of ChatGPT. So now you know, guys, how AI research can be extremely valuable for companies. I also explained to my client that this will be an R&D project, and I made sure to explain to him there was a possibility that it won't lead anywhere. Of course, I also told him that based on my experience and my friend's experience, that I was confident we could have some pretty satisfying results. So at the end, he was comfortable with the idea of taking this risk. Then I proposed to him that the project would be divided into 3 steps, and each step would involve its own contract. Here are the 3 steps I showed him. The first step is to train a first version of the AI models. The second step will be to fine-tune them to increase their accuracy. And the third step is to integrate those models into a user interface for the end user. And don't worry, guys, I will go through each step in detail. So as you can see here, we go to step 2 if the client is happy with step 1, and we work on step 3 only if the client is satisfied with step 2. Now, obviously, the highest level of risk is step 1. Step 2 involves less risk, and the third step is the least risky because at that point it will be mainly software engineering. Okay, so now let's dive into step 1. We need to train AI models that will extract the measures accurately. But any AI project where you train AI models needs a high quality dataset. In the AI world, there is a famous quote that says garbage in, garbage out. It means that if you feed an AI with data of poor quality, it will not be able to learn properly, and at the end the quality of its output will be very bad. So basically I need to collect all of their technical drawings from their past clients and their corresponding inspection report documents. I also need to do quality control on them, resize them into the same size, and most importantly I need to label them. Labeling means marking the areas of interest with the right labels. I'll show you now what I mean. As you can see, for example, in this image, we are marking those 4 different areas with 4 different colors to tell to the algorithm, hey, those are 4 categories that we want to detect. This labeling will be done in both a manual and semi-automated way, meaning I will add some of those labels myself one by one, but I can also use an AI model to do that for me, but I will have to double check manually anyway if the labels are good. Getting a good quality of dataset is the most critical step, and this data labeling step will be done 4 times, each for an AI model, and I will tell you more about that later. Obviously, this step will require me to sign an NDA because I will be handling their proprietary data. Another step will be something that we call data augmentation. It's basically when you take an image and rotate it or you flip it, and this artificially increases the size of the dataset, which is always good for deep learning projects. Finally, I will have to split the data for the training and testing of the AI models. Usually we split the data in either 80-10-10 splits or 70-15-15 splits. It means either we use 90% of the data for training and validation and then 10% for the testing of the AI model, or we use 85% of all the data for training and validation and 15% left for the testing of the AI model. Okay, so now let's talk about the AI models that will be trained. By the way guys, when I say AI models, I mean neural networks. If you're not familiar with this term, just Google it or ask ChatGPT. Neural networks are the foundation AI models of modern deep learning. So any model that you heard, ChatGPT, Midjourney, Llama, Gemini or Claude, they're all neural networks. There will be 1 model to fine-tune and 3 models to train. Fine-tuning means taking an existing pre-trained model and feeding it with new data. The data you want it to learn, basically. The model to fine-tune will be responsible for detecting characters inside an image. They are called OCR models, and OCR stands for Optical Character Recognition. They take as an input an image and the output text. I decided to fine-tune this model because I know there are already open source AI models designed for OCR which are pretty accurate. Part of my job will be to select the most accurate and fastest one. Now let's move on to the neural networks to train. Basically, those models will be responsible for detecting different areas of a technical drawing. They are called object detection models. Object detection answers the question, what is it and where is it? We're trying to have a good answer for the 2 questions. It's pretty hard if you think about it. So basically the output of those models are the name of the thing we're trying to detect, as well as a bounding box in terms of coordinates, to have a rectangle that surrounds that object. The first model will be trained to detect the text areas. The second one will be trained to detect the different views in an image, which all belong to the same object. And the third model will be trained to detect all those areas that are not important. The third model is not mandatory, but it's highly recommended because we'll use it to clean a drawing from useless data that we don't need, so that the text model will be able to focus only on the area of interest and the whole system will be much more accurate. So the experiments I'll conduct will be about training a model, but also about something in deep learning we call hyperparameter tuning. It's basically changing some variables inside those models and seeing if it leads to an increase in accuracy. The objective is to find the parameters that lead to the highest accuracy. The model I'll be using for object detection is called YOLO v9. It's the 9th version of YOLO. It's a very famous object detection model, known for its accuracy and speed. Also, it's a model that doesn't require millions of data samples, so it's good for this project. The next thing I will have to do is to develop an algorithm for ranking the measures in a clockwise way. I thought about the algorithm and it made sense in my mind. Let's take this image as an example. So we said we started with coordinates or measures that are on the bottom left. So we will rank all the bounding boxes, all the rectangles with the coordinates that are the minimum in terms of x and y coordinates. So those will be on the bottom left, and then we start from that measure, and then it's like we expand, the area around that measure until we collide with another measure, and then this will be the next one. Which is our second measure, and then we do the same thing again and again. So this is how I thought about the algorithm. It shouldn't be that hard to implement. Now the main objective of this first step is to achieve 80% accuracy in recognizing the measurements in the test set. If we achieve that, we'll consider this step as a success and we'll be able to move on to step 2. Now the main goal for step 2 is to improve the AI models we have so far. I will collect the client's feedback and I will identify opportunities for enhancement. For example, let's say the system is very good at extracting the measurements from some types of drawings, but it can't do that very well in some other types of drawings. Maybe we can increase the number of hard data samples and retrain the models. This step will really depend on the results from step 1. Now the main objective is to reach a text accuracy of 95%. You will notice I didn't say 100%. If you're watching this video and you're not familiar with how AI models work, there is no such thing as an AI model with 100% accuracy. You can look up AI research papers, and on all papers that use a metric that goes from 0 to 100, you will never find 100. You can find 99, 98, 97, and so on. The reason is that AI models are based on probabilities and approximations, and it's always about training the AI model on some data and applying what the AI learned to new unseen data. And then of course I will validate the results with the clients via a demo. So once the client is happy with step 2, we'll be able to move on to step 3, the last one. One of the requirements from the client is that they want something to be working locally, that does not rely on the internet. Basically, this step will be about designing and building a web interface that the machinists will be able to use. Since the AI models will have to run locally, I will also have to advise them on what kind of computer they should purchase for running these models. So I will advise them on the type of GPU, motherboard, CPU, and so on for this computer. This step will also involve playing with the Google Docs API so that we can create Google documents on the fly based on the extracted measurements. By the way, once an AI model is trained and we want to use it for new data, we say we're doing inference of the model. So I will also have to make sure that the inference is as fast as possible. I mean, the whole point of this project is to save time, right? And I will also have to validate the UI and UX with the client. Finally, there are two critical points in this last step that will have to be developed. The first point is an explainability module. You remember I told you there is no 100% accurate AI system? Well, the client still doesn't want to miss any measurements. So every time the AI system produces the Google Doc, we want a human to see the confidence score of the AI as well as from where those figures come from. I had the idea of displaying a button explain or something like that. And it will output side by side the input drawing and its doc equivalent with arrows for each measurement, so that in a few seconds a human will be able to double check if everything is correct. The second important point is a part of the system dedicated to something that we call continuous learning. Basically, when an AI model has learned and we're happy with the accuracy, this is not the end of the story. The AI model needs to keep learning based on new data, otherwise its performance will decrease over time. Because that's how the world works. The software that produces those drawings will probably increase its resolution over time, meaning the data quality will change over time, and if the AI models don't keep learning, well, their accuracy will just decay over time. So I will include in the AI system the ability to add labels to new drawings and to fine-tune the AI models with these new data samples. This will obviously involve a crash course I will design for them so that it will be easy to do. Now we move on to the most interesting part, the cost breakdown. First, let me show you a table with the cost of each step. So the first step will cost $25,120. The second one will cost $10,000 and $250. And the third one will cost $26,500. Now let's move to a detailed breakdown of each step. So this is the table for all costs linked to the tasks of step 1. My hourly rate is $150 and I estimated the number of hours based on past research projects. As you can see here, I clearly told the client that part of the fees will be dedicated to consulting with some other AI experts. I'm in for full transparency with all of my clients. I also charge for client communication and reporting. Now, obviously, these projects will involve weekly meetings with the client. I will actually not report to the CEO directly, but to their chief operating officer. I will also use cloud GPUs for training and fine-tuning the models. Actually, cloud GPUs allow you to parallelize tasks, meaning you can train multiple models at the same time and to be super efficient. And I don't know yet if I'll be using Google Cloud or AWS. I put a $2 per hour of GPU cost, and I estimated around 310 hours of training / fine-tuning. You can clearly see from this table that the most tedious tasks will be the dataset creation as well as the models training. Now we move on to the cost of step 2. The main cost drivers are model retraining and validation and testing. Finally, the cost details for step 3. You can see here the costs for computer parts and advising on which parts to buy. The main cost driver is web interface development. And you can also see in the very last line a course for continuous learning, labeling, and updating the model. I also thought to share with you guys why I decided to take on this project. Because some people will think, hey, a business is willing to invest money in an R&D project, so why not just take it? Well, actually, this is a computer vision R&D project, and if you go to my agency's website, you will see that most of my research experience and interest, in fact, is not about computer vision. Even though I published 2 papers where I used computer vision techniques, I decided to focus my agency Neura first on conversational agents and time series analysis. So to be honest, at first I was afraid to be incompetent at this project. I'm always thinking long term, and my main focus is client satisfaction, not short-term money. So after I asked the opinion of my 2 AI engineers friends and realized that first, the methods I would be using were not that different from what I used to do in research, and also there were good chances to achieve good results with the qualitative approach. After this, I decided to accept this project. But if, for example, I thought the problem was too complex and it was very hard to achieve something meaningful, I would have not accepted this project. Okay, so now I want to tell you guys about some interesting things about the sales process. The proposal that you saw is actually the 3rd version of my proposals. The first 2 that I showed the clients were rejected. The first one was about building only a prototype that included a small part of step 1, and it was for about $8,000. The main reason for rejecting the proposal was that they wanted to have full visibility and total cost of the whole project. The second proposal was almost exactly like the one I showed you, but it didn't include the course. And instead there was a 4,000 monthly retainer where I would be the one doing the continuous learning of the AI models. The reason for rejecting is that first, 4K per month was too expensive for them. And the second reason is that they don't want to depend on anybody once the system is built, which is very reasonable from them. I also want to tell you the time it took from our very first meeting until the final yes. Our very first meeting was on the 3rd of July, and the meeting where they agreed on everything I showed you was on the 20th of November. So almost 5 months between the first touch point and the close. During this period, we had 7 meetings where I had to ask them questions, understand the problem, show them slide presentations about the solution I thought of, and also showing them the 3 proposals and answering their questions. In total, the 7 meetings lasted for a little bit less than 4 hours. Actually, 3 hours and 15 minutes to be specific. A fun fact, they didn't know what's the current level of accuracy. Remember, they didn't want to miss any measurements. So I thought, okay, the AI model needs to be at least as accurate as the humans, right? So I asked them, what's your accuracy level when doing it manually? They knew they sometimes missed some measurements, but they don't track it, so they don't really know their own level of human accuracy. In the final meeting, the CEO asked me one important question. Who will own the AI models? I reassured them that they will have full ownership of not only the trained AI models, but also the annotated and labeled dataset. In the AI world, both of those things are considered extremely valuable. It's obvious for a trained model, but having a dataset ready to be ingested by AI models for training is super valuable. It means that in the future, if some researchers decide to open source a foundation model for manufacturing which is accurate, it will be ready to ingest this data. Now I want to speak a little bit about the technical side in case you want to know. The technologies I'll be using are mainly Python as a programming language, and PyTorch as a framework for building and training the neural networks. I'll just speak about the tech I'll use for step 1 because the other steps are dependent on the success of step 1. I also want to talk about the level of skills required to complete this kind of project in case you're a business owner watching this and you want to make your next big move in AI. First, you need an ML engineer, machine learning engineer, for the building, training, and validation of the AI models. Basically an ML engineer for step 1 and step 2. A research engineer is also qualified for this project. Actually, a research engineer is more qualified for steps 1 and 2 because it's pure research at that point. For step 3, you need both a software engineer and an ML ops engineer. The software engineering part is for the design of the web interface and backend of the solution. An ML ops engineer is needed for the deployment of the AI model and making sure the inference is both accurate and fast. Now, even if I define myself as an AI/machine learning engineer, I also have research skills because of my experience, and I also have software engineering skills because I developed full-stack complex web apps before starting my AI agency. However, I lack the skills of an ML ops engineer, so if things go sideways during step 3, I might outsource some of the work to an ML ops engineer. So this was my video presenting the backstage of my AI agency Neural First with the case study of a real AI solution for a real problem. I hope it was informative and that you learned something in it. Don't forget to seize the opportunity of me building you an AI/automation prototype for only $750. This is only for the month of January 2025 and it is limited to 4 seats only. So hurry up if you want your AI prototype. Cheers guys!